Hello, my name is Dave Shane from Boston Engineering. I'm going to speak today about a Phase 2 SBIR under topic N141-042, what we call Climber. Boston Engineering Corporation is a small business located right outside of Boston, Massachusetts. We're a well-established engineering services organization that supports commercialization of clients' technology as well as some of our own. Systems engineering experience, 20 years of experience in robotics and marine engineering. Our centers of excellence are shown down in the bottom left: robotics, control systems, embedded systems, digital transformation, and DFX, meaning design for manufacturing, design for assembly, etc. To maintain an effective force posture, the United States Navy needs to maximize the operational availability of its vessels. This is a specific concern to particularly unique platforms, such as aircraft carriers and submarines. Tanks inside of those platforms can provide significant uncertainty during maintenance and retrofit activities. The United States Navy needs to balance maximizing this ASABO while also ensuring a safe working environment. This safety environment can come at an increase in documentation, an increase in cost, and potentially a decrease in efficiency when personnel are subjected to more of the more challenging environments, such as confined spaces. Operations inside of tanks and inside of confined spaces represent the majority of the unknown additional time that's required for shipyards during retrofits and during maintenance activities. As such, the United States Navy could benefit from a system that can complete inspections and/or surface preparation, surface remediation sooner in the availability by limiting the amount of human access that's required inside of a tank environment. Could also benefit from a system that can maneuver inside these complex and confined tank spaces and execute inspections and other activities. Can benefit from a system that can interface with other current and future inspection tools, and can absolutely benefit from a system that supports current shipyard tactics, techniques, and procedures. Boston Engineering solution here is called Climber. This is a remotely controlled, highly maneuverable robotic platform for inspection of complex internal tanks of ships and submarines. Climber's advanced maneuverability provides continuous access within a ship's tank, even transitioning through tank wall thresholds. Our key capabilities: fundamentally, this system is viable to remove personnel from tanks. We can maneuver from one tank bay to another through a standard common threshold. We can integrate with a broad range of end effectors, tools, and inspection or remediation devices. We have the ability to access an incredibly high percentage of the overall tank. Key innovations that support are inherent inside of Climber: a novel in-wheel downforce adjustment, leveraging ROS2 software implementation, and inherent onboard obstacle sensing. The current status of the Climber program: we're in the process of initial system demonstration and confirming the maneuverability plan. We're executing arm and sensor integration currently, and we're working very closely with Portsmouth Naval Shipyard to provide direct user feedback and access to particularly relevant testing environment. If we look at calendar 2022, we'll integrate ARM and initial sensors into the system and execute a full tank demonstration. As stated, Climber is a remotely controlled, highly maneuverable robotic platform for inspection of complex internal tanks for submarines and other surface vessels. The advanced maneuverability is a key asset, providing continuous access throughout the entirety of a ship's tank. A feature, advantage, and benefit table is shown below. But summarizing, the front and back magnet arrays minimize the requirements for operator access by maximizing the system maneuverability. Doing so and operating the system via a game controller minimizes the overall vehicle training that's required, and leveraging ROS2 reduces time and complexity to introduce new, novel, and innovative subcomponent technologies. Boston Engineering's goal with Climber is to transition it to the fleet. Our initial focus is on combined NAVSEA and shipyard funding to provide trial units to the major public submarine shipyards and the regional maintenance centers. Acquisition beyond this intermediate NAVSEA and shipyard funding we expect could occur directly with the shipyards, possibly executed under a broader Phase 3 contract. Some key transition advocates and potential sponsors shown below, as well as some additional funding opportunities. Maybe most important, FY22, we expect to have our first prototypes. FY23, we expect to have additional prototypes with the opportunity to expand into the market, get some of these vehicles into users' hands, and FY24 potentially provide a system for purchase. Boston Engineering is no stranger to transition and partnering to deliver effective technical solutions. Our manufacturing and distribution plan is already in development for Climber, and the team will leverage as much additional parallel support as possible, including likely state of Massachusetts transition and innovation grants. We, as a company, are interested in meetings with PMS 555, PO subs, PO ships, related project managers, and other companies working in the shipyard robotics and inspection or remediation fields. We're also interested in opportunities to present and collaborate with other public, private shipyards and shipbuilders. We're interested in expanding application spaces to others with similar needs. Naturally, that could increase the subassembly quantities and drive down costs for all. Thank you so much for attending this brief. My name again is Dave Shane from Boston Engineering. Please reach out with any questions. Hope to talk to you soon. Thank you.